welcome to today's talk show. And in this talk show, we're going to discuss labor and mechanization. And we brought a good panel of experts here, two of us joining physically here at the table, and two of our experts are joining us digitally from the UK. And on my right is Carlo van der Weijen. He's the General Manager of the Eindhoven AI Systems Institute at the Eindhoven University of Technology. Hannes Oberholzer is also joining at the table. He's the Global Product Manager Brassica for Hazera. And Alistair Hewen is joining from the UK. He's a Brassica Research and Development Consultant at Greenyard Frozen. And Mike Phillips is joining us too from the UK as a Managing Director at RoboVeg. Before we go into the subject matter, let me introduce the guest to us. Carlo van der Weijen, you are General Manager of the Eindhoven AI Systems Institute. Yeah. Welcome.
Thank you, thank you.
Yeah,
happy to be here.
Please elaborate a little bit about what you do.
Yeah, my institute develops all kind of artificial intelligence applications, so robotization, etc., for all kind of industries, health industry, mobility, but also agro and food. I must say it's not my professional background, by the way, but I do have some background because I grew up and I've been born on a farm where we harvest a lot of asparagus. So in all modesty, I'm a very skilled asparagus picker. But yeah, that's less valuable to be so because it used to be the vegetable that was hardest to automate, but now you see all these applications already coming up worldwide. So that's the theme of today. How we're going to mechanize even that, and more will be mechanized. So that's
fantastic. And you were part of something that seemed science fiction a long time ago, but now is reality.
Actually, it comes always a little bit faster than people expect. So let's discuss this.
Very exciting to hear your insights. Thank you so much for joining us, Hannes. You are joining us, Global Product Manager Brassica for Hazera. What do you do?
Yes, so as you say, indeed, I'm the Global Product Manager for Brassicas. I'm more or less having an oversight of all the markets we have globally. Yep. And I'm the connection between our markets and our breeding activities. So more or less taking the market information and translate that back into breeding objectives. So my background is, I can call myself a seedsman. I was, soon after my studies, I got involved in the seed industry. Yeah. It became my career. And for most of these years, I'm involved working for Hazera in different divisions, in commercial, in product development, and the most recent years in marketing. I have experience in many crops, a little bit in glasshouse production, etc., but most of my experience is in open field production, in several crops, not only the brassicas, but more on that, yeah.
Fantastic, a lot of knowledge with you as well. Happy at Hazera?
Very much.
Great,
indeed.
fantastic.
Yes.
Joining us from the UK is Alistair Hewen. Alistair, you are a Brassica Research and Development Consultant at Greenyard Frozen. Alistair, can you tell us a little bit more about your expertise?
Yeah, I've had a lifelong experience in vegetable production. In senior management with a major Scottish vegetable producer for fresh and frozen industry. More recently, over the last 5 years, I have worked with Greenyard and Greenyard Frozen, and they are one of the largest frozen vegetable operators in Europe, with factories in UK, Spain, Belgium, France, and Poland. My operation, or what I'm trying to help with, is developments in particularly Poland, UK, and to a degree Spain. We're looking at how we can take things forward and try to really push the operations hard so that we can grow more and grow more efficiently.
Right, thank you so much, Alistair, and also for joining us all the way from the UK today via digital connection. And then also joining from the UK is Mike Phillips. You are the Managing Director at RoboVeg. Mike, what does RoboVeg do?
RoboVeg originated out of a company set up by two of my fellow directors who, for the last 10 years or so, have been dreaming of building an automated broccoli harvester. When in my other role at Envisage Systems, I was approached by these two directors to basically try and do the clever stuff, do the image processing, the electronics, and the robot communications. I sort of said, yeah, we'll take this on as a project. A year ago, I suggested to them that having succeeded in that, we set up a company, RoboVeg, to actually produce these rigs and do it on a professional basis that was capable of supporting the world market. So that's my role.
Fantastic. Thank you, Mike. And I look forward to hearing more about the developments that you've had with that company, especially in this industry, which is also changing quite rapidly. And I can assume that that's quite something spectacular. Right, let's move on to the first part. I'm going to come back to you, Alistair, first. You've had many years of experience and have seen many changes happening over the last decade in the horticultural world. Now, what is, in your opinion, the most urgent problem today?
The whole of the Europe, if not the world, but we're only talking of Europe here today, a massive shortage of harvest workers, or labour generally, to harvest vegetables, to plant vegetables, to tend vegetables. And, you know, that's only one sector. You know, the whole of Europe is looking for workers. And it is, you know, even in places like Eastern Europe and Poland, I've just returned from Poland over the last hours, and we have seen a significant amount of Ukrainian workers coming into Poland over recent years. That's not happening anymore. They are staying more at home, they're not traveling. So we're seeing a massive shortage of workers to do the job. So we need to look at ways of trying to solve this problem. It's a serious problem.
Right, so thank you, Alistair. And Carlo, you work on making machines perhaps as smart as human beings. What is your vision on this?
Yeah, of course, Mike is also doing his bit, and a lot of other industrial partners as well. But this is typically for any industry where there's a lot of low-cost labor, a lot of manual labor, that they scream for solutions for technology, and technology is going to happen. The thing with technology development is actually that it's always overestimated what it can do on short term and a little bit underestimated what it will do on the longer term. And that's actually, you see now these two trends fighting with each other. On the one hand, technology is popping up. It's solved already a lot of manual work. And, you know, we used to be 70% of people used to be farmer, and it's now only 3%, and that's all technology what already happened. But we're still not there if you listen to Alistair. So on the one hand, you have, yes, technology will come to save that, to help, and to assist even further as they're already doing. On the other hand, and that's also been mentioned by Alistair, you see also that the living standard is going up, which on the one hand means that we need even more food, more products, more luxury products, more experience, and everything that we can add value with. People will pay for it because living standard worldwide goes up. But it also means that people are not so open anymore to just move to another country to assist in harvesting. Yeah. And I think in general, and you see this in a lot of other industries as well, which we're going to talk more about, but actually I foresee that for the next half to full decade, so 5 to 10 years, probably these two trends will still balance and we will remain with the problem. Hopefully the technology will make sure that it does not get worse because of this increased demand. And then after that, it is generally expected that technology will kick in and all the inventions from Mike and other ones will come up to really decrease the number of these repetitive jobs.
Right. Yeah, thank you for that. Mike, do you have a vision also for the next 5 years?
I certainly do. And just to reiterate what the previous two gentlemen both said, we talk to farmers in in many, many countries around the world. Everyone has the same problem. This is something that really caught me by surprise because I thought there must be the odd country out there where they don't have a labour problem. And it's absolutely not the case. Everyone, from America to New Zealand to Australia, anywhere you talk, they have all got the same issue. I would suggest that we are on the verge of a revolution in the agricultural market. The timing is now there. There's a huge impetus because of the labour shortage. I suspect we would have got there anyway, but as Carlo is saying, 5-10 years down the road, the labour problem is exacerbating that and forcing us to come quicker to market. And I believe that's going to happen. As Carlo says, there are a lot of people working on this around the world, and we just happen to be one of those. The only other thing I would say at this point is that the experience I have of walking through fields, I won't say every week, every other week, and a farmer says, you can do anything you like with this field because we cannot harvest it. We are going to plow this product back into the ground. And it's quite heartbreaking.
Definitely. Now, Hannes, do you hear the same thing from your industry?
Yeah, indeed. I think it's a tension not only in terms of the availability of labor,
yeah,
because I mean that's in theory you can say there's ample labor available, but there's a huge lack of interest in careers in the practical part of the vegetable production. But I think from what Mike is saying, across the world, you hear this. It's also a matter in terms of, or connected to efficiencies.
Yeah.
And so in terms of speed, details, accuracy, etc.
Right.
So it's not only driven by the lack of shortage, but also by efficiencies.
But then has also the role of the farmer changed quite a bit already?
I think it changed in the sense of scale.
Yeah.
Like you just said earlier, in the past, a huge percentage of people were involved in agriculture, and today you see less and less, also impacted by mechanization for a large part. But that trend is continuing, and I think there's a shift between small-scale farmers and becoming real enterprises on global businesses on a much larger scale. So indeed, yes.
Yeah, right. Now, Alistair, you've dealt with farmers all your life. The role of the farmer, is it very different now?
Yes, it's changed. Mike's correct. We're on the edge of a revolution, but perhaps the revolution has been happening. Throughout my career, when I look back, the changes in mechanization that's happened has been significant. It's just that it's been fast forwarded a little bit recently because. I have seen the people coming out of the coal mines that when the demise of them, they were looking for work and we got them into the fields. And then really from then onwards, we saw the Eastern European people coming in and helping us harvest vegetables. Fantastic workforce, fantastic. But now that with less people, we're looking far more quickly to the changes. And we have seen some massive changes recently, with the mechanization of transplanting, mechanization of weeding. We are seeing improved varieties, but I think we'll come on to that later perhaps, but that's the next large part. We need Mike, but Mike also needs help from the seed industry, and that's when Hazera can come and help us.
Absolutely.
Great, thank you for that. Well, as you said already, Alistair, we are all looking towards mechanization as a possible solution for the future, and already things are happening in mechanization to be able to perhaps help with this problem going on. And we're going to talk about more in depth into mechanization in part 2. Right, we're going to continue with part 2, and as discussed in the first part, there is a big shortage of labor. It's a problem that is affecting the entire industry, and one of the solutions that might be able to at least soften that problem is mechanization, and mechanization driven by artificial intelligence. Carlo, you are specialized in artificial intelligence. Perhaps it's good to describe exactly what we have to consider artificial intelligence.
And what we can expect, yeah. It's good that maybe first is to talk about the definition of artificial intelligence. It's kind of a buzzword that's often being misused. There's no fixed definition, so I tend to say that actually it's about machines starting to act like humans, and doing so also assisting us. And they always did, by the way, but until now, machines mainly replaced or assisted our arms and legs with physical work. And now they also start to replace or assist our brains. And that's actually a very exciting thing that's happening now. So all kind of pattern recognition, so they can recognize how fruits should be identified, what's the leaves and what's the crops, what's the fruits, etc. And that's a very interesting next step, which you see now happening. And then always comes up from, okay, these machines being just as intelligent or even more intelligence than we have, how is the distribution between their role and our role? And in abstract terms, you could say that in the future, all the work that's being done just by coloring inside the lines, applying rules, coloring inside the lines means just applying what you do, repetitive work.
Yeah.
Leave that to the machines. They're better than that. That's not the most interesting jobs. And we do the work that's creative, coloring outside the lines without things getting out of the hand. That's kind of the distribution, how the future will look like. That means that these repetitive jobs in also the in the farming, that's going to be done by machines for sure. In 100 years, there will be no harvesters anymore. In 50 years, I think also not. 30 years, perhaps most of the work is already being done. There's an interesting session, by the way, tomorrow on agriculture in 2050. But the interesting question is what's going to happen for the next 5 to 10 years. And that's in all segments where they predict that automation will come and release all these jobs like order pickers, truck drivers, all this kind of, they're screaming for these kind of solutions. And you see that it's coming up. Technology is already assisting, but it doesn't make truck drivers, order pickers, and all these kind of people redundant yet so far.
No.
And that's the exciting next 5 to 10 years where we really foresee that this exponential rate of improvement of technology is going to assist.
Yeah, but well, do I understand it correctly? First, we can, of course, tell a computer what to do, and then they'll do it. But now we've reached a stage where a computer can decide itself what to do, or not yet?
The decision is a very important thing, of course, and it will be able to take its own decisions within a framework. At least I hope so, because otherwise it gets very dangerous as well. And that's another discussion, of course. But it will, these very interesting and important things on top of mechanization, that it start thinking on the squeezing power, recognizing fruits and vegetables and how hard can I squeeze it. We immediately know this as human beings. Yeah. These are skills that machines also will learn in the near future. And that makes the possibilities of technology exponentially more powerful than it is today. And that's the exciting thing that is coming up in the next decade.
Right. And now if you look at other businesses, what do you see happening?
Yeah, as I said, it's very similar. The truck drivers are a very nice example. That's a very repetitive job, just driving a truck. A computer would be able to do that. And 10 years ago, people said, let's not train truck drivers anymore because you would train them for unemployment. In 10 years, trucks will drive themselves. That's what we said 10 years ago. Luckily, we didn't stop training truck drivers because the practice, that's what I already said. On the short term, we overestimate the technology. On the long term, this will happen, but not on the short term. You should not now already decide to say our technology is going to save us. It's not going that fast, but at a certain moment it will come. And the same happened with the truck driving. This will, I think still in 10 years we will need truck drivers, but probably they can do this sleeping while driving for a couple of hours, so that actually the system gets twice or maybe 3 times more productive. That's also how we should approach it. So we can produce much more with less people already in the next decade.
Great. Mike, you've also dealt with the development of intelligence to be able to assist already. As Carlo also said, there is the idea that sometimes we overestimate or underestimate the development of these technologies. Do you feel that you were ahead of time, or do you feel like you're still catching up?
That's a very interesting question. Technology is moving on at such a rate, and in my other life as a vision system integrator, we see this all the time. Now, the beauty of where the technology is going is it opens up opportunities in the field of agriculture. And this is obviously what I'm concentrating on now. I'll give you a perfect example. We have always said from day one of RoboVeg, one day we'll invent an autonomous vehicle instead of having a tractor driver and a tractor pulling one of these rigs around. Well, of course, the current situation has made that speed through. We're now actively talking to people who are producing these autonomous vehicles. So the dream is now, and I don't think it's that far of a dream, we can have 2 or 3 of these harvesters in a field with a single supervisor with a remote control. All the fields would be mapped out. The autonomous vehicles would just be carrying the automatic harvesters around. 24 hours a day, 7 days a week, whatever you need, guaranteed to get the crop in. And we are not far off this at all at the moment. So much so, we are planning on doing a trial with an autonomous vehicle probably in 3 or 4 weeks' time. That's how confident we are.
How much labor would that reduce on average, Mike? Do you know?
Huge amounts. If you take a typical broccoli crew of maybe being 9 people, Alistair would probably be better qualified to tell me that. We've obviously removed those people from the field. They're the people who actually do the cutting. Now we've potentially taken the tractor driver away. And I'm not obviously trying to take people out of work, but at the end of the day, driving a tractor at a very slow speed through a field for 24 hours a day is not a job for anybody, as Carla was saying. It's incredibly boring, and it really shouldn't be necessary.
Alistair, do you feel that the agriculture is changing as fast as the rest?
Yeah, it's changing, and I think it's been changing significantly over a period of time. The change is speeding up. And I think what I'm looking for is end-to-end solutions. There's no point of taking labour out of the harvesting, but you've still got to be there for weeding, or still there for planting, or in our case, in the freezing industry, you need a huge amount of labour then for floretting, cutting the broccoli up into florets. We need an end-to-end solution. And I think we've got part of the solutions coming in, and I think that you guys around the table are likely to help the industry.
Carlo, will there be a farm that is completely run without people in the future?
The lights out factory, as they tend to call it, yeah.
Maybe
a part of the farm can be a lights out where you don't see any humans, like what you also see with autonomous auto manufacturing, car manufacturing. That's used to be done by a lot of people, now only a few people, but still at these car manufacturers, a lot of people work there, and that's the thing. We should not be too afraid of this, like being cutting jobs. As I said, 70% of us were farmers 200 years ago, now it's 3%. It's not that the 67% of difference is without a job. We created new jobs that added more value. And that will also happen with these jobs that we want to replace, and that's also going to happen within the farm. There will be new kind of jobs that really add value instead of this boring work. We should embrace this kind of technology. So this should not be a negative thing. This improves the work, it improves the productivity, and improves the product. So we should really embrace this kind of technology.
Hannes, what do you think?
Yeah, I agree fully. I think the only thing which is really relevant is that we should not underestimate the time it will take.
Yeah.
You talk about machines that needs to run in field conditions. It could be wet, it could be dry, it could be muddy. It's sandy soils, clay soils. So there's a lot of variables that you need to take into account. But if it can contribute to a part of the work solution and bring some relief, it's already progress made. So I think every step that you can get closer to full automation is progress, and it would be appreciated. But yeah, it might take a little bit longer than tomorrow.
Yeah, Hannes says an important thing. It might take a little bit longer. Often people use the examples as Kodak, which disappeared because they didn't see digital photographs coming, or the encyclopedia industry that totally disappeared because we have Wikipedia. Now, Wikipedia is 100% digital. It doesn't have to have with these physical conditions, etc. So in a physical world, to my regret, it doesn't come as fast because you have to work with these physical rules. There's no 100% digital alternative for food, luckily. No. So it doesn't go that fast, but it doesn't mean it doesn't come exponentially. It can come fast at a certain point.
Yeah. Alistair?
Yeah, I think that I do agree that we're looking for end-to-end solutions. However, I just would say that that we have a lot of climatical problems in the field. We've got to take in the rain, we've got to take in the clay soils, the wet days that need significant additional management. So thinking that a farmer can run his farming operation from his office, I think we've got to think again. And it's going to be a part of the solution. It's going to be a big part of the solution, but we'll never do away with the management. But perhaps the management or the people we're requiring in the fields offer a different caliber and a different training from where we are today.
Any additional comments, Jens?
I think when you see things are invented, and as they became available, it's integrated into mechanization. Like the example about the, let's say the camera abilities and visibilities, etc. It was things not included in mechanization in the past. It's, so we will see things coming step by step, but indeed the speed is it's increasing, and we will see more and more efficiencies on a larger scale, I expect. But I agree, there should be some observation and some management always on the field, on the farm. It might be a little bit different when you move towards glasshouse production and there's high-tech farming, etc. But as long as we are farming in nature, in soil conditions, for sure, I think there will be careers for people managing farms.
Right, and now one of the people here has already, put these mechanical developments into action. Mike with his company, and we're going to discuss that in part 3. Right, we discussed the rapid changing developments in a variety of industries and looking at the future and how artificial intelligence is developing around the world, and especially has an impact on the agricultural business as well. And Mike, who is present here, already has a company working on mechanical harvesting solutions. Mike, can you tell us a little bit more about your company?
Certainly. We initially set out to produce a broccoli harvester, broccoli being one of the major crops on the world market. This has obviously been our focus to date. When we started out, there were basically 4 major challenges to overcome. Number one, I suppose they're all critical, but of real importance, the image processing, the ability to be able to separate the crop from the surrounding, the leaves, the soil, whatever it needs to be. And coupled along with that, therefore making decisions about what technology to use, because everyone thinks if we just say image processing, well, you stick a camera on it. Now, a camera to someone in the industry means nothing. There are so many different types of cameras. So, and certain different cameras are used for certain different crop types. They're more suited. Illumination is another critical one. If we're to run 24 hours a day, we need to supply our own lighting system, which has to work in bright light and in night conditions. Then there's actually the cutting technology itself. Again, we've come up with a very good solution for broccoli harvesting. It's not actually perfect for lettuce harvesting or asparagus harvesting or any of the other things I'll mention later. So we have to have various solutions available. There's actually making the robot or robots do something useful, quite complicated, although becoming less so as time goes on. And then possibly the biggest challenge of all is to take all this technology, which in itself is pretty complex, and make it simple. And this, to me, is the biggest challenge. We want either an autonomous vehicle, as I've already suggested, controlling this, or the other case is a tractor driver actually controlling the machine. So, we're not expecting someone with a degree in computer science to be driving the tractor. We have to make this very simple, press a few buttons. The harvester that we've come up with is a selective harvester. So it calculates the size of the broccoli head before actually making a decision to cut. So a farmer is able to say, I'm only interested in something between this size, and it will leave all the rest of the crop in the field. Now, the powerful thing that we're implementing on the system now is that any crop that we leave behind, we will map and produce a tabular form of data for the farmer to actually look at and say, well, okay, if I need to harvest more broccoli in 3 days' time, this section of the field is where I need to be targeting because it's very close to this size already. So we're implementing things like that. Now, because obviously we've undergone quite a large marketing campaign across the world, we are forever being approached by farmers who want us to look at different technologies, different crop types. we're looking at so many different options. Unfortunately, we don't have the resources to develop them all at the same time, because they all need new image processing, they all need new cutting technology, but the basis of the machine is there, which is very powerful. And I guess essentially our aim is just to enable farmers to concentrate their energies on the quality of the crop they grew and the best planting patterns, and not have to worry about how they're going to harvest it in 3 months' time or 4 months' time. We'll take that problem away from them. That's essentially what we're trying to do.
Right, that changes quite the philosophy of work as well. And now I believe you also have a video, or we also have a video of this machine, and we're going to look at that right now.
If I could just explain,
yes,
just before you play, I just want to note that it's not a nice marketing video. This is literally a video we took from mobile phones during demonstrations in the field. It was also, I believe, a field that had already been harvested, so there wasn't that much broccoli around, but it was a perfect demonstration of what we did.
Fantastic. Let's have a look. Very impressive video, Mike. Any response here from the table?
This is technology going on. So this is the little bit more than not only the mechanical work, but also the pattern recognition and the cameras, which get so much better in the last years and also in the upcoming years, do their thing. Because this is not the work that a child is want to be in the future. They don't want to be order picker or broccoli cutter. No, they have other dreams. So let's do this mechanization as fast as possible. That's one interesting thing, that so far you can also adapt the vegetable to the automation to make it easier recognizable.
Yeah.
And that's of course something that also Hazera specializes in. And this is going to be more of a cooperation, I guess, in the future.
Yep. Let's look at that. I just want to just have Mike have a few questions about the machine still. So can you explain a little bit in detail what we just saw?
Essentially, what you're seeing is as the rig passes through the field, there are, on that particular model, 3 cameras constantly scanning the field, looking for any broccoli heads that it can find. Now, I'll come on to whether it will work in every situation in a moment. Right. But as soon as it finds a candidate head that it will measure it, it will then pass those coordinates to the robot system, which will cue all the ones to be cut. Now, obviously, the tractor is constantly moving throughout the field, so all this movement has to be tracked. So the coordinates of the camera can then be translated into the coordinates of the robot when it's available. The robot then says, yep, I'm ready to cut. A PLC triggers the blade comes in, picks up the broccoli, puts it in a box or on a conveyor or whatever the actual farmer wants. And it's as simple as that. The only thing that we don't do at the moment is we don't handle automatic box changing. At the moment, that's up to the farmer to decide how they want to actually handle the boxes of crops. But that is what's going on. Advanced image processing, in this case, standard image processing, as opposed to what we would call deep learning, which may be another term that I have to use later. But it's still very effective, and it works extremely well on broccoli. It wouldn't work, for example, on lettuces or asparagus. That would need a completely different approach. But that is what you're seeing.
Yeah, because Carlo already said that earlier. You know, as a human, you know how tough to squeeze a certain vegetable, how you know how breakable it can be. Is that a limitation that you see in the machine as well?
It's certainly something that we cannot handle at all at the moment. Given time, we would do it, and I mean speed within the actual field itself, it's possible to add that technology. But one of the things that we have to keep up with, of course, is the speed of harvest, and therefore the yield that the farmer is going to get. The example that you've seen of that machine, by the way, is what we call an RV1, which is a single robot unit capable of handling 3 rows of broccoli in the field. We at this moment have an RV3, which has 3 robots, which deals with 9 rows of broccoli as well.
Thank you, Mike. And it was a really impressive demonstration. Alistair, as someone with the history of brassica research as you have, what was your response to this?
I think it's a fantastic step forward. And I think that given time, that I'm sure that Mike and his team will develop this even further, so that perhaps guys like myself who are looking to floret broccoli, that Mike might devise a system when he's handling it. There's no point in handling it again. If it's there, we can floret it and keep going. So I see this as a great step forward. However, I would say that Mike can't do this on his own. I think he needs guys like Hazera to do significant breeding, and it will help Mike speed up his operation. That's my view. I think it's a part of the journey, and it's a fantastic part of the journey.
Right, yeah. Carlo also mentioned this before. Apologies, we're coming back to this now. Is adapting the vegetable to the machine.
Essentially, that's what we actually always did. The breeding in order to make it better and more healthy, but also easier to harvest. And that was part of the breeding process and to optimize. Now that the machines get more intelligence, maybe they will meet in the middle. How you can breed the vegetable in such a way that it's easy to harvest, but also how can we make the machines more intelligent. So this should be a cooperation between the people making the machines and people making the seeds.
Hannes?
Yeah, I first of all have to say congratulations with the development of this machine. It is quite impressive. We know it's not easy. It's a dream for many years already to have machines that can harvest. And I think this example of the broccoli will set the pace forward. Indeed, the big question is really, are you developing the machines according to what is existing? Or do we need to adapt the plants to make it adaptable to the machines?
Right.
And I think it is a process that needs to work hand in hand to be able to change the plant and the plant types, etc., to change them genetically in terms of their appearance, physical characteristics, etc. You need to understand what is the obstacles in mechanization to be able to make the changes in the plant, unless you can envision them. But that on itself is it's a time-consuming process.
Right.
And it needs to be in balance with all the other characteristics which we would like to have as well. We cannot only focus now on mechanization. We need to keep in mind the consumer and their preferences in terms of food quality, characteristics, etc. So it's not a single path we can take. It's really we need to look at it holistically, but then step by step and understanding what is the limitations in the mechanization so that we can adapt accordingly in balance with all the rest. Yeah.
If I take the example of the broccoli, how would you go about this in adapting, of making it easier adapted to the machine? Or is that a too much detailed question?
No, I made an observation of the video and I was wondering how this machine is actually measuring where to cut the broccoli, how deep down the stem.
Right.
Because if you really cut it too high, you really turn it into florets, and if you cut it too long, you sit with waste, which also need to transport. So, and I'm sure that Mike had this challenge already with his team.
Yeah.
And obviously the solution as well. The question is really, is the product ready to go into the final packaging? Or do you still need manual hand labor afterwards to trim it?
Mike?
Lots of questions there. If I deal with the cut height first. Yes, you're absolutely right. It's something that's thrown at us many times. There are two versions of the software. One, if you're in a flat field and everything tends to grow to the right height, you can just set a cut height and everything will be cut that distance from the robot datum point. Otherwise, we have a 3D sensor actually in the cutting head itself. As the robot lowers the sensor, lowers the cutting head towards the product, it triggers and says, here's the top of the broccoli, and the farmer then has put in and said, I want to cut 120 millimeters below that, whatever the figure is. So that's how we deal with the cut height. I would like just to re-emphasize something that was said earlier about liaison and working with the seed manufacturers, the growers, because it's critical that we do get the varieties right. You said, the question was just given that can we literally package that product? Well, the answer is probably no, depending on variety, because of the prevalence of, or the presence of leaves. We, as yet, haven't found a technology which will get rid of all the leaves. We get rid of some of them, and we get rid of quite a few, but not all. And if the consumer or the supermarket are going to still require the fact that there are no leaves on there, that becomes a problem for us. The only other thing I would say is the planting pattern as well. This is another thing that we have to communicate with all the farmers. It's all very well saying, yeah, you can automatically harvest. We have to have a cutting head that is big enough to go over a piece of broccoli, for example. If the next piece of broccoli is planted too close to that one, we will smash every other piece of broccoli. So we always discuss with every farmer that we're talking to the planting pattern. And it's often the case that we can come to an arrangement whereby we just suggest a slightly different pattern, which doesn't affect their yield, but does suit automated harvesting.
Right, okay.
Indeed, and this is typical the examples I was referring to. So knowing the needs or the obstacles in the mechanization part can give us direction in terms of how to change, how to improve the plants themselves to be more suitable to this mechanical harvesting process then. Yep.
Maybe one small remark, because there's also a market mechanism working here. If you have a sort of vegetable that's very easy to automate, the harvesting, then it also will be cheaper to harvest it, and it will in due course also be cheaper to buy it, and it will be more popular.
Yeah.
So that's probably also a market effect, that the easier you have your seeds and to be automated the harvesting, the popular it's going to be. So there will also be a market mechanism pushing towards more automation.
Yeah, and a market mechanism probably making it less interesting to get difficult vegetables.
Exactly. They will become more exclusive because they still need manual labor, etc. Right. That's also a marketing effect. But this is an important thing, that if you have the seeds that can easily be harvestable, then it will be more popular because cheaper.
How long would it take to breed a vegetable when it's more suitable for a machine?
Listen, I don't want to say it will take me as long to answer as long as it takes, because it really takes very, very long. Yeah. But I think it's important. It's not only that. It's a matter of having quality food and available to the masses at an affordable price. Yes. And this is actually the whole argument. So if you cannot solve these issues people face today mechanically, it's very likely that some of the food products will become extremely expensive and less people will have access to them. But with improved mechanization, it might be remain available for the bulk of the populations globally. Great. But in terms of plant breeding, it's a process that sometimes our ambitions are higher than what we really can achieve. But you work within a spectrum of genetic variability, and you have your parameters. So let's talk about the broccoli leaves, for example. You have upright growing plants and you have widespread open plants, and I think if I listen well, it's also about the number of leaves that's creating physical obstacles for the harvesting. And these type of characteristics you can influence by plant selection and breeding and making crosses, while you still remain let's say the actual quality, type and head and color and shape, etc., and weight what you would like to have. But so you do it in steps towards a certain direction within the germplasm of the specific crop type. But if I say 8 plus years, it's not unrealistic, likely to be more.
Okay.
Depending, but as you see, it's in this specific case of the broccoli,
Yeah.
I mean, it's happening. It's there already. It's fine-tuning what we talk about. So in that case, probably there are less drastic changes to make than the example you talked about earlier about the firmness of a crop and how to feel how firm it should be or not, etc.
Right.
So let me conclude by saying there are traits which can be easier modified than others.
Thanks, Hannes.
That's technology being developed, and with Mike doing his fantastic work, we will see in 10 years that the pressure of the workforce, what we talked about, will be significantly starting to be helped by technology.
Fantastic, thank you. Carlo, Alistair, I started with you, so I'm going to also close with you. Alistair, do you have any advice for those watching now, based on the information that we've discussed today?
What I would say is that mechanization that's required by agriculture today is not to save money. It's not about cutting costs and giving cheaper food. Forget that. It's not going to happen. What it is, it's about sustainability in our vegetable industry, because what we're getting to just now is a house built on sand. And I think with the work that's been talked about by Mike and with Hazera's breeding, world breeding, that is the future. That is where we're looking for, sustainability in vegetable production.
Thank you so much, Alistair. And we're closing off the talk show now. I want to thank our experts here, Carlo, Hannes, Alistair, and Mike. Thank you so much for joining us here for these discussions and sharing your expertise and insights with us. I want to also thank you for watching. If you have any questions, please do contact Hazera. They're happy to assist you or bring you in contact with one of our speakers as well. And have a lovely, lovely evening. Bye-bye.